Welcome to Tuesday, June 30th. If you need to finish up the work from yesterday, feel free to do that. I know that was a really crazy long video. I'm going to try to not make today's video that long. You have 3 pages left after you get that stuff done in that Moon Interactive kind of thing. And then there's 2 questions to answer about the formation of the moon. You will be reading some articles about the moon landing, watching a couple short videos, and telling me if you think it was fake or if it was real. And please give me like concrete reasons, because that's the interesting part for me to read. Yeah, so that is today. So today, as far as the moon formation and Earth goes, you will just be summarizing what you went over yesterday and kind of pulling it all together. This is the first page. I'm going to show you this video. It kind of summarizes everything really nicely. So here it is.
There's a fundamental connection between our studies of the origin of the moon and the physical samples that were brought back by the Apollo mission, the actual rocks from the moon. When those rocks were first studied, we learned several very significant things. One, we learned that compositionally, those rocks are extraordinarily similar to the upper layers of the Earth. If you look at an element like oxygen, its distribution of different isotopes of oxygen is essentially identical in the moon and the Earth, whereas it's very different in meteorites from Mars or the asteroid belt. Another clue, another constraint we learned from the Apollo samples is that the moon rocks appeared very dry compared to Earth rocks, almost as if they had been heated to a high temperature and that they had lost the elements that tend to vaporize easily upon heating. And that suggested to us that the process that formed the moon must have been a high energy event. So we think the moon formed when the Earth was struck by a very large object as the Earth was forming. So this would have been a separately formed planet that was vying for dominance in the inner solar system along with the Earth and other growing planets. But it collided with the Earth and ultimately was absorbed by the Earth and gave birth to our moon. So in terms of the impactor, which we often call Theia, we think that based on its mass, that it would have been as big as the planet Mars. Before it collided with the Earth, it would have had an iron core and a silicate mantle, like the Earth, and it would have had about 10% of the mass of the Earth. We think initially the inner solar system had maybe 20 small planets, and it was through collisions between these planets that we eventually ended up with our final 4 terrestrial planets. Now, the last of these big collisions on the Earth was the one we think formed the moon. The reason that we focus on a Mars-size impactor is that that is the impactor size that if you hit the Earth with a Mars-size impactor at an off-center angle at the expected speed, you will start the Earth spinning with about a 5-hour day. Now, that's a very rapid spin rate, but it turns out that is what is needed to agree with our current 24-hour day with the moon at its current distance. The moon is moving away from the Earth. So we know when the moon first formed, it was much closer to the Earth, and the Earth was spinning much faster. So the idea that the moon formed by this giant collision with the Earth was first proposed in the mid-70s. And yet, we couldn't test the idea initially. For smaller scale collisions, you can perform experiments in the laboratory, but you can't perform an experiment of what happens when 2 planets collide in any laboratory setting. To do this, you need to build a computational model to simulate the planets and their response to the collision. We can use our computer simulations as, in essence, a virtual laboratory to test how the outcome depends on things like the size of the impactor, the impact speed and angle, and use the overall results to assess the likelihood of forming a moon like ours. So we're simulating this final large collision with the Earth. From the perspective of someone on the Earth at the time, what you would have seen is an enormous object approaching the Earth, many, many, many times larger than the full moon in the sky. It would have hit the Earth at an oblique angle, on a time scale of a few hours. An enormous shock wave from the impact would have propagated around the entire surface of the Earth. The vaporized rock from the initial impact point would have been ejected out, and it would have flowed around the entire Earth. And the Earth would find itself enveloped by a thick atmosphere, but not like an atmosphere we know today. This would have been an atmosphere of vaporized rock with a temperature of more than 5,000 degrees. The momentum, the force of this collision, is enough to start the Earth rotating very rapidly. And so only hours after this impact, the Earth has a rapid rotation rate. Now we think on a much longer time scale of about 100 years. That disk will cool, the vapor will condense, and out of that disk, through collisions within the disk, the moon would have grown and accumulated. So although we think we have a good idea about how the moon formed, the exact details of this event are still being debated, and this is in large part a testament to how those samples that were returned decades ago are still driving active science debate as ongoing analysis provides us with more clues from those samples on how the Earth-Moon system formed.
This page is basically just summarizing your understanding. So there's a table and it has the moon data, surface rocks, and then Earth information. So basically what we're asking you to do is just tell us what moon data about surface rocks can tell us about Earth. So for example, I'll just do surface rocks, right? So surface rocks. Surface rocks of the moon can help us figure out what minerals the moon rocks are made of and how that could have helped form the Earth. Because remember, they say the moon and the Earth formed at roughly the same time and only one of them got to be a planet. So that would be surface rocks. And then the composition of the moon, how does that compare? What does that tell us about the Earth? The density of the moon, what does that tell us about the Earth? And you can feel free to use that packet from Monday as well. I feel like probably a lot of the answers are in there. Yeah, so that's page 11. And then the very last page is just basically this. So while the giant impact hypothesis is the current leading model on lunar formation, it leaves some issues unresolved. For example, if Theia came from elsewhere in the solar system, it would likely have contained different ratios of oxygen isotopes than Earth, resulting in a moon with different isotope ratios. Surprisingly, however, the isotope ratios of oxygen and many other elements from Earth and the moon look essentially identical. So that's what they were saying, that they're pretty sure the moon was just a planet, a protoplanet. We just aren't sure where it formed. Many variations of the giant impact model have been proposed to address this. So why do they have the same? Coincidence could be one of them. Number two, they could actually have had different compositions, but the vaporization and mixing of materials from the impact evened out the differences. So maybe when the moon hit the Earth, that giant impact actually transferred materials. Aspects of the impact occurred differently than originally thought. It could mean that we don't have it right. So those are three hypotheses about why the moon and the earth have basically the same composition. And here's some. Do you hit earth? Some little graphics that kind of give you some information. You guys have all of this in your packets, so you can look at all of that. So the final thing you have to do is there you have a page that has 2 questions on it. The first question is use the evidence you've learned in this lesson to make an argument for whether moon rocks and other evidence, so all that whole list of things that we went through, would be helpful in learning about the early history of Earth. So why do you think all of the information that we gleaned from the moon could help us figure out how Earth formed? So what is it about the moon formation that can help us learn about Earth, like a paragraph? And what do you think about this? So, and then there's just the basic question is, what do you think? Like, do you agree with this? Is there too many unanswered questions for you? What are they? Why? Or do you agree? And what was the thing that kind of made you go, oh, this is why I agree with this giant impact hypothesis for the formation of the moon? So those are your 2 questions. Now at this point, you guys will be doing a little fun activity about the moon landing. All right, so the Apollo space program. This is the moon landing stuff. So the first article that you have is this article. It's the Apollo space program. So this is just an informational article to give you kind of a background. I'm going to let you read most of it yourself. I will hit some highlights for you. The first thing that you need to know is that the first moon landing took place in 1969, and the last moon landing took place in 1972, which means that 6 of the flights landed on the moon. So a total of 12 astronauts walked on the moon. It tells you a little bit about what they brought back with them. Yeah. And then it just gives you kind of a history of each of the different Apollos. It's called the Apollo program. Each of the different Apollo flights and what happened. And it tells you how they did it and why was it important at the time. So in the 60s, in the 1960s in the USA, why did we feel like this was an important thing to actually do? And that is this article. The next article that I have for you is this Time article called "The Moon Landings Were Faked," and it kind of goes over what happened. Why do people think it was fake? Why was that buzzing around for so long, that the moon landings were all faked and that they were just filmed in a film studio? This kind of goes over it, and it's just really short, but it kind of gives a good concise, like, this is why people thought that. And then the last article just proves the article. It's not super long, but I mean, it's like 3 pages. And it just goes through 5. The moon landing is fake because the American flag looks like it is flapping in the wind. That's a reason people said the moon landing was fake, and this sort of debunks that. The moon landing is fake because you can't see the stars. And then the next couple paragraphs debunk that. The moon landing is fake because the shadows aren't right. So this talks about the shadows and like why they aren't right. The moon landing is fake because you can't see Armstrong's camera. This kind of tells you where the actual camera was actually mounted and why you couldn't see it. The moon landing is fake because Stanley Kubrick filmed it. So this is why people thought maybe Stanley Kubrick, who's a film director, filmed it. There's this movie called 2001: A Space Odyssey. And then why that's, it was real. So my opinion is that it was real, if you haven't figured that out. And I couldn't really find any great articles that had anything about like why it was fake for sure. So these are just sort of telling you what the theories are and then how people who believe it was real like sort of debunked those theories. So you can kind of go over these. It'll just give you some pointers. And then the very last thing I'm going to tell you is there are 2 short videos that also sort of do this. So if you would rather just watch those videos than read the articles, they actually will tell you the same information as this article for sure. And those will be separate links. All right. Talk to you guys tomorrow.